Good morning, good evening, good afternoon, and welcome everyone to Cambridge Technology's webinar on building data lakes on Amazon Web Services. I want to do a little bit of housekeeping just to get going. There will be a Q&A portion at the end if we have time. If not, please put your questions into the question box and we'll get back to you as soon as possible. Again, today we're presenting part of our Beyond Prediction series, Building a Data Lake for Machine Learning with AWS. Our presenters today are Nitin Tyagi, who's our Vice President of Enterprise Solutions, and my name is Peter Buckley, Vice President of Sales for Cambridge Technology. We'd like to let you know also that the Beyond Prediction series is a continuing series, and we will have, or you will receive an email or have received an email inviting you to participate in a Redshift on Amazon and a Machine Learning on Amazon Web Services webinar coming up in the next weeks. And stay tuned for others. We'll continue this series as we move through the different technologies that are available through Cambridge Technology and Amazon. We want you to know that we have been engaged with our customers building enterprise value with big data and cloud for quite a long time. We've been building data warehouses for many years, and we began our data lake practice about 2 to 3 years ago. And we'll continue to help our customers to build database solutions. A little overview on on Cambridge Technology. We were founded in 1999, and we provide a full service IT consulting services platform. Today, we have some notable partners that we'd like to let you know that we engage with. One is Confluent, then Atlassian, and OutSystems. We're a focus partner with Confluent and their data streaming platform in Kafka Apache. Again, we provide a full set of services, but to enable our services, we provide certifications in CMMI Level 5, ISO 27001, 20000, and we're an Amazon Advanced Tier partner. Again, our full service suite, we provide AI services, cloud services, big data, and application, pretty much everything underneath those headlines that you might need in your IT journeys. Again, we provide cloud and big data services. We operate with all the major cloud providers, Oracle, Amazon, Microsoft, Google, IBM, and private cloud. And we are also a certified cloud managed services provider. And you can visit us for more information at the website noted below, wemanagecloud.com. There are several things that I wanted to point out, that we use technology partners for growth and differentiation. And again, the key partners we're trying to work with today are Confluent, OutSystems, and Atlassian around the big data services that we provide. And we will continue to offer those as we move through your IT journey. We have these Amazon competencies. We're an advanced tier consulting partner. We have big data, Oracle, DevOps, managed services partner program, or a channel reseller, marketing, consulting partner, solution provider, and a well-architected partner within the Amazon network. Again, I'd like to thank you for joining us. I hope that this webinar is enjoyable and that you learn as much as you possibly can to help you get started on your data lake journey. I'm going to turn the microphone over to Nitin Tyagi, our Vice President of Enterprise Solutions. Nitin, it's all yours. We're having a little technical difficulty. Give us a second and we'll be right back to you. Sorry about that. Again, sorry for the delay, but here's Nitin. Thanks for your patience.
Thank you, Peter. Sorry for the technical difficulties. To begin with, we want to quickly walk you through the agenda. In today's session, we are essentially going to talk about characters of a data lake, just give you a context of how data lakes have matured and how we have come to this. We're going to essentially look at big data architectures. Then we essentially will get into basics of building data lakes and various services that Amazon provides. We'll walk you through a couple of architectures on AWS data lakes and discuss the next steps. But first things first, as we get into it, is what is a data lake? An enterprise, from a purely a definition point of view, an enterprise data lake is a large storage repository that holds vast amounts of raw data. This data could be structured, unstructured, semi-structured in its native format. The key words to highlight here is until it is needed. So the flexibility of a data lake is basically you can essentially use it until it is data. You can define the structure in which you want to process it. So the primary question comes up is why data lakes? And how have we come to, we traditionally, if you look, even Cambridge Technology has been running enterprise data warehouse last 20 years. But traditional business analytical processes were very different. And the way that we have moved so far has been typically as we look at enterprises. Enterprise start with defining the user requirements, typically reporting needs of a business. Once the business defines the business needs, the next logical step in the whole process is define the database schema and the queries which are needed. So once the data sources are identified, the traditional process of ETL, data extraction, transformation, load happens, and then the reports are created. That's the traditional way that we have been dealing with data so far. However, in all of this process, if we go back and retrospect, all the data was not stored. Only the data which was needed was stored and utilized and discarded after use. That's changed since then. In the last 10 years, we've seen a lot of growth in terms of data, be it from commercial platforms, be e-commerce, shopping carts, credit card transactions, be it social media, HubSpots, Twitter, Facebook, Google Ads, voice, and or things like Google Maps. Everything gets integrated into enterprise apps today. Or data from third-party verticals like sensor data, cell phone data, telecommunications, and whatnot. There's so much of rapid growth, especially around the IoT space. The data sets that we deal with has tremendously increased. And the challenge is combining the transactional data from operating systems, which is stored in traditional relation databases, with the less unstructured data, and then providing the right information to the right people in the right format at the right time. So that's, if you speak to any business today, that's the key big challenge that any enterprise data teams are facing today. However, if you look at today, the big data thinking has changed. The concept the companies are adopting is all data has potential. Companies have been hoarding data, and the way that traditional data warehouses are maturing or evolving as into data lakes, where there's no predefined schemas, and apps and users interpret the data as they see and need it. So, so the classic ways of storing, analyzing data sets is changed and matured over the years. Now, going back and looking at the way that any enterprise or an organization can look at building data lakes or data platforms, there are two classical approaches of developing this. One is a traditional top-down approach, where you create a hypothesis or a business need, and you essentially build up the confirmation, or then is a bottom-up approach. And classical ways that data lakes form is a bottom-up approach. And we'll walk you through some of this in the next slides. So using a top-down approach, if you look at it, the corporate or the enterprise defines the corporate data strategy. The business analyst gets into gathering the requirements, technical requirements, business requirements. There's implementation phase where teams are essentially working on reporting, analytics, dimensional modeling, ETL. The infrastructure teams are setting up the infrastructure. So that's the traditional way we have seen enterprise data platforms evolve over the years. And once that's done, there are multiple various analytical platforms, be it Tableau, be it QuickSight, be it OBI. There are multiple analytical platforms which were developed over it. We've seen data farms, data warehouse farms, and whatnot come over the years, but most of them followed the traditional top-down cycle. However, the data lakes uses the bottom-up approach. When we look at data lakes, the concept or the philosophy is you ingest all data from various devices, social media, web, sensors, whatever it may be, store all the data sets, and then do your analysis when you need it, as you need it. You essentially, data lakes provide you the flexibility where you could run batch queries. You can run interactive queries in real time. You can build data warehouse out of data lakes and whatnot. So the concept of a data lake is very different. And if you're thinking about building data lakes, you need to essentially and have an existing data warehouse. It's going to be a change in mindset as you approach building this. And classically, the way that we have seen large enterprises implement data warehouse is basically a combination of a data lake and a data warehouse to complement respective needs. A classic data warehouse is used for what descriptive analytics or diagnostic analytics, why it happened and what happened, whereas a data lake platform is being used by enterprises for predictive analytics or prescriptive analytics, things like what will happen or what can happen. So there's the way the adoption of a classical data lake is we see a trend mostly towards machine learning, AI initiatives in these organizations. And as we go through following slides, we essentially will walk you through a couple of use cases. But let's go back to the definition of a data lake. Data lake helps you store unlimited amount of data in a very inexpensive way than your traditional enterprise data warehouses. It allows the data to be used on the need basis. And classically, your schemas are defined just in time based on how you need it. It complements your existing data warehouses. So in the next few slides, we're essentially going to look at classical data lake architectures as we've seen evolving and various use cases that we've dealt with. Classic use case that we see on the screen is the enterprise data warehouse augmentation. So many customers who already have an existing data warehouse build data lakes to complement the workloads on a data warehouse that they may have. The challenge with that becomes that the existing tools, which BI analytical tools, which are working on a classical data warehouse, might not necessarily be supported on the data lake or the data hub, as we say. The next model that we have seen is building data lakes as data hubs as temporary staging, refining, and for reporting needs. The challenge in a data hub model, basically, a data hub is a staging area which is essentially used for data collection. The reporting platforms do not work on the staging area, which creates another set of challenge. So companies have evolved over that and then went in with an all-in model where they essentially used a data hub for a total solution without an enterprise data warehouse. We've seen companies follow this approach where most of the data is stored in a data lake or data hub platform. The challenge with this kind of platforms is the queries are slower And there's a lot of retraining needed in people's tools and technologies. And then we've seen the modern data warehouses. This is classic. This resonates as we go in, as it's a evolution of all the three scenarios we saw earlier. You basically use a data lake, which acts like a data hub, which feeds into a data warehouses, and your reporting platforms works both on your enterprise data warehouse and on data lakes. So it helps you address the need of your predictive analytics and also prescriptive analytics, and while you're also doing your analytical reporting on your operational systems. So in the next part of the presentation, we're going to talk about how do we build data lakes on Amazon using S3 and the various components that are involved. To begin with, simplified architecture view of a data lake is the three major components. You have ingestion mechanism in any kind of data platform. You need processing needs, something that can take the data and process it. And then there are consuming needs where analytical platforms or reporting tools comes into play. But a classical data architecture would have source systems as described. There could be multiple operation systems. The ingestion, Amazon provides you with a huge set of ingestion mechanisms, including Kinesis for streaming your IoT devices or streaming platforms or your mobile data sets. Kinesis is a real-time streaming platform that Amazon provides out of the box that you could plug in. You could use Direct Connect in case organizations have large data volumes that they want to move to Amazon S3. You could essentially use Direct Connect. Or if you have petabyte scales of data, Amazon provides you with a service called Snowball, which could be used to move petabyte scale of data onto Amazon S3. If you're not familiar with data migration services, if you have classic relational databases, Amazon provides you with a data migration service where you can move data from your classical SQL, Oracle databases, or MySQL databases onto Amazon S3 using data migration services. There are also elements like S3 Accelerator, which can be used to transfer data to S3. But that's about data ingestion. Amazon provides you a huge set of services, and these services keep evolving every year, every day. They get faster, better, and cheaper as we speak every month and every quarter. The next element, which is I think is the most critical, is the process. Once the data is in S3, it needs to be processed. And Amazon provides you with a bunch of services. To begin with, the first service on the list is Amazon Athena. Athena is an interactive query service. It makes you easy to analyze the data in S3 directly using a standard SQL. So you can essentially start, once the data is in S3, you can use Athena to start querying data in S3. Athena is a serverless service, so it's no infrastructure to manage, and you're using it as a service. The next and most important service is Amazon EMR. EMR, as all of you must be aware, it's a cloud-native big data platform. It lets you process vast amount of data quickly and cost-effectively. Again, it uses open source tools like Apache Spark, Hive, HBase, Flink, or Presto. Plus, it provides you scalability of EC2 so that you can scale as you need. The third element, which if you're familiar with, is Amazon Redshift. And these are elements where it's a choice that you make. Once you have your data in S3, you can essentially query it with Athena directly, query it with, put the data in an EMR and process it, or you could store it in Amazon Redshift. Redshift is a petabyte scale data warehouse service from Amazon. It is used to process massive parallel computing needs. In fact, if you're interested, we have a webinar next week where we essentially are talking about Redshift and how could organizations move their SQL, Oracle, any kind of on-premise data warehouses to Redshift. So I believe this webinar is on 25th. We're specifically talking about Redshift, the cost gains, performance, and things that you need to take into consideration. The next service that Amazon provides out of the box is Amazon Elasticsearch. It is nothing but your classic Elasticsearch. It essentially this is a service that Amazon provides. It's a fully managed Elasticsearch service. Makes it easy to deploy, source, and operate Elasticsearch at scale, and with zero downtime. And a classic use case of Elasticsearch, you essentially can look at your log analytics and search for building your real-time managed services and whatnot. The last but not the least, as companies grow, Amazon provides you a bunch of AI and machine learning services. Again, we have a webinar tomorrow where we're talking about AWS machine learning services, where we'll introduce you to some of the out of the box or the Amazon SageMaker platform. As we go into this, the last element, so we looked at three elements. Let me go back to the basic. Ingestion, we looked at the whole set of services where you could get data into S3. We looked at process, how you could get data into Amazon and process. What are the various platforms? Athena, EMR, Redshift, Elasticsearch, and Amazon AI and machine learning services. The last and most important is the consumption. How do you consume? So Amazon provides you out of the box quick site. It integrates with Redshift, Athena, EMR to essentially provide you analytical reports to your teams. Not just that, once you have implemented this, you essentially can have your data science team work on the data lake. You can plug in your Jupyter notebooks, start writing your model and start doing the modeling, leveraging the huge compute powers that EMR provides. Or you essentially can have API gateway implemented where you essentially are running APIs to fetch data from the data lake and do real-time processing or reporting needs as well. So Amazon provides you with a whole infrastructure set of services, scalable, with zero downtime, that you essentially can plug in any of your data needs to build a data lake. In the next few slides, we're essentially going to talk about three important elements of a classic data lake, or which Amazon provides, which are the fundamental foundation to building data lakes. The first things that we have to make is AWS Lambda. Lambda is a trigger-based code execution engine, which helps you in real time to do serverless task invocations to various services. Amazon Glue, it's an event-based serverless ETL service. And Amazon EMR, which we did discuss in the last slide, it's a Spark or Hive running on Elastic MapReduce. These clear, but the key is, as we build data lakes, you're essentially looking at a couple of elements. How do you clean your data? How do you transform your data? How do you concatenate, convert, format? How do you schedule your jobs? How do you do event-based transformations? How are your transformations expressed as code? So the way that data lakes or today's big data platforms are being designed is very different from the traditional ways of building enterprise data platforms. And Lambda, Glue, EMR provides you with these capabilities where, for instance, you can use Lambda to do event-based driven transformations. Based on certain events, you can run your transformations, or use Glue to do serverless ETL computing. So in this session, we're going to focus on Glue. Glue is a fundamental foundation of building the data lakes. Now, Glue is, if you look at the ETL, when you need the ability of a data lake platform, is you essentially can take the data from your data sources and use Amazon Glue to provide ETL on need basis. You can essentially plug in with Lambda for event-based transactions. So for instance, as you get real-time events, you can perform your ETLs on real-time events, do your extraction, transformation, and loading based on real-time events. So you can use a combination of Lambda and Glue to perform ETLs. Taking a step back, just to give you give you an overview of what a Glue is. Glue is a fully managed extraction, transformation, and loading service that Amazon provides you. for all your analytical needs. This is out of the box. You can create and run ETL jobs with a few clicks using the AWS Management Console. Now, some of the elements of Glue that I just wanted to introduce you are, it provides you an integrated data catalog. So it provides you the data cataloging capabilities, automatic schema discovery. So assuming that you have a data source which has changed over the week, it essentially lets you, and we'll go into some of these details in more detail, but it provides you automatically discovery service of schema changes, if any. It lets you generate code. It helps with data cleaning or duplication of the data sets. It has a flexible job scheduling capability. And it also provides you developer endpoints where your developers can plug in and start working on some of these transformations. So the key element that Amazon Glue provides is metadata management. So Glue, the core or the backbone of a data lake on an Amazon S3 based solution is the Glue data catalog. It's a central metadata catalog for your data lakes that helps you search the metadata. It defines your connectivity. It helps you with data versioning. It helps you with data classification. So Amazon Glue data catalog is a foundation or the fundamental backbone on which a data lake is built up. The way that Glue works is it has a set of crawlers which essentially keep crawling the S3 data sets to essentially detect any schema changes. Partition, in case your data has increased significantly, it essentially partitions the databases so that you essentially, when you run ad hoc queries, the queries runs optimally. So the behind the scene magic of a data lake, which is built on Glue catalog, is a data crawlers, which essentially do all the magic behind the scenes. So when you have real-time data or queries, you have data in real time where it performs, as I was mentioning earlier. The Glue data catalog does classification of data based on the data sources. You have, be it from Redshift, be it from CSV files, JSON files, structured, semi-structured, unstructured data. The classification is supported by AWS Glue. The next aspects that Glue support is data catalog. So it essentially catalogs all your source systems, including the properties, statistics, row count, column count, type, table schema. So all the metadata, which is of your structured, unstructured, or semi-structured data is being cataloged by Glue. And the other aspect, which is very important, common, your operational systems keep changing from time to time. There would be new columns, new tables added to your operational systems. As you get these data or export them into S3 via data catalog, it also does the version control. So the system knows if anything has been dropped, updated, changed, or modified. It has a catalog. So when you run your new queries or things, the Glue data catalog has an inventory of this. In addition, the most important when it comes to enterprise data warehouses or big data problems is table partitioning. It also manages the partition automatically so that at runtime, the performance is optimal. So if you look at the data lake, the Amazon Glue catalog is the secret sauce behind building the data lakes, which has a catalog services. It is a Hive compatible metastore. So you essentially can write your queries right from Athena into Glue. You can use Amazon EMR to query the Glue because EMR uses Glue for catalog information that it has about data sets from the source systems. A Redshift can plug in directly into Glue, which is Hive compatible as well. It's a metastore which is used to profile or classify your source data and catalog it, which becomes the foundation for everything that a data lake supports. Now, as we get into further, the various use cases that can be implemented in real time. We have seen cases where a lot of time when you say real-time applications, be it mobile applications, be it need real-time analytical processing. So Glue or a data lake can stream into uh, Amazon Kinesis Analytics, where based on real-time events that happen, you essentially can relay using the API gateway or mobile applications plugs into analytical Kinesis analytical services using the Amazon streaming platform to capture data, events in real time and process them. The key is of um, the data lake, or the beauty of the data lake, is you write once, catalog once, read multiple times, and ETL anywhere. So based on your needs, because once you move the data into the S3 bucket, you catalog it once. You can read multiple times. Most of your data sources, you can in parallel query the same data source using any of the processing. You can use Athena to query it. You can use Redshift, EMR, and you can use ETL using Glue to either work with quick sites or a reporting web services or any of these directly. So it provides you a hybrid environment of and capabilities that traditional data warehouse not necessarily support. So take a step back and look at the characters which are this. You essentially can collect anything. You can essentially dive into anywhere using any of the services that Amazon provides or open source technologies. It provides you flexible access and it is future proof. So in case you have data structures which are different, in case you have source systems which are new, it still would support them seamlessly. And you don't really have to worry about redoing your ETLs or doing a new refresh project and whatnot. It is all supported as a service, scalable as you need. So traditional data lake architecture, as you see on the screen, is you essentially can use the AWS Data Lake console or Data Lake CLI to essentially launch the service. It plugs into most of the Amazon services, from Amazon S3 to Glue to Amazon DynamoDB, Elasticsearch, CloudWatch for monitoring and IAM access purposes. Athena, again, it plugs into, uses Glue to query data directly into S3. You essentially can use Lambda to do real-time analytical processing and on-demand jobs. And you can plug with API gateway for real-time processing needs. But this is a classic data lake architecture you see on the screen. The way that the beauty of this is you don't use any servers to manage this. These are all Amazon services that are being used on demand. You can scale up as you need it. Else the data is stored in S3. It could be used by various teams as they need it. It could be, you could provision them for their business needs. You can charge back for business needs. So all these beauty of that Amazon provides in terms of chargeback from an IT infrastructure perspective. However, the core elements that it helps you scale thousands of data sources if you need to. It have virtually infinite storage. You might store as much as data as you need, and there are various storage services that Amazon provides you to manage and optimize your cost. You could write interactive queries right to S3, which is a storage, or you can move the data to EMR or a Redshift to process it. It's highly available, and again, you only use it and pay as you go. Amazon also has a lake formation. These are cloud formation kind of scripts which you essentially, they've made freely available that you can use to do a test run. It essentially brings up the, you essentially can script uh, your data lakes as you need. So as and when you essentially have to launch services, you can launch on demand. There are multiple quick starts that you can use to evaluate data lakes as needed. I just want to emphasize on this. So as and when organization needs data lake, you essentially can script out your crawlers, ETL prep, everything that every organization is different. They use different set of services. You might use EMR, you could use Athena, or you're using Redshift directly based on what you need. You can use lake formation scripting. This is very similar to cloud formation that lets you essentially script your data lakes. As and when you need it, you launch the script, it provisions a data lake for you. You use it. Once you're done, you can shut it down and move forward. So again, just to recap, traditionally, a data lake provides you with the flexibility where you can ingest a lot of data. It provides you the agility with Glue. It is secure and compliant for various needs, including ISO 27001, FedRAMP, DoD, and PCI needs. And virtually any size of big data application, be it real-time streaming needs, be it large petabyte scale data warehouses, you essentially can support. Again, with Cambridge Technology, we've been uh, building data lakes for the last 3 years. We have been involved in supporting enterprises with building data warehouses last 20 years. We've traditionally done the Oracle, IBM, Microsoft data warehouses, and since then evolved into building data lakes. This is new, but it is a change in thinking as you move from enterprise data warehouses to data lakes conceptually, but in terms of the benefit to the organization, both in terms of cost, time to provision infrastructure, it's been a real helpful. But with that said, again, AWS provides you the benefit with AWS is it provides you integrated services where you can use Redshift, AWS, MySQL databases on RDS. Everything's plugged in. If you have operational systems are built on some of this, where you essentially can output any of these, all these services work with each other seamlessly. You can have identity and authentication with AWS IAM built in. So everything works in unison on the AWS services. The key thing that we have used, CTE does a lot of work around machine learning and AI. And the way that we have looked at data lakes from our perspective is they complement your enterprise data warehouse strategy. So organizations who have data warehouse unable to scale it have been using data lakes for their predictive modeling, prescriptive analytical things. It helps you complement and accelerate that whole journey where you're switching from analytics to prescriptive analytics. And very quickly, with the benefit of SageMaker and other AI and ML services, which essentially complement some of this. So a data lake is a perfect solution for if you're looking at AI and machine learning modeling for different data scientist analysis team in your teams. Peter?
Thanks, Nitin. We're drawn to a close. We have a question or two after this, but there's a number of things that we want you to remember. Again, that data lakes are flexible, agile, secure, and capable of handling all of your data needs. If you look at the engagement model, what we ask you guys to do is to look at and identify use cases in advanced analytics or even data science. A very important question, is your data ready? And if it isn't, and that's one of the great things about data lakes is it utilizes all forms of data. But if you need help with that, we can also help there. And then how do you take that first step? And we can help with that as well. There are some contact information at the end of the presentation. Again, we'll send out the webinar to all participants so that you can see that again or listen to it or pass it along to people within your organization. We'd be happy to evaluate an AWS data lake via POC, or if you'd like to have a demo or a live demo, let's have that conversation. And some organizations may even qualify for a joint Amazon and CT funded POC. So please connect with us, with me or somebody at sales to discuss those specific needs, and we can get that going for you.